A pleasant day, STEM students. Today we are now on our second week of discussion for Chemistry 2, and with your knowledge of the intermolecular forces of attraction, such as the hydrogen bonding, ion dipole forces, and the van der Waals forces, we will now be able to tackle this particular topic. So let's start first with liquid. So right now I'm sharing to you my screen. So, properties of matter. So, for this one, okay, it is related to the movement of molecules in the liquid and thus to the intermolecular forces present. So, with viscosity, it's actually intermolecular forces of attraction that exist within the liquid substance that enables it to resist the flowing motion. So, nonpolar molecules like benzene, pentane, and carbon tetrachloride experience only weak intermolecular forces or London dispersion forces, and low viscosities. More polar molecules like glycerol and aqueous sugar solution or syrup have high viscosities because of the hydrogen bonding among their OH groups and dispersion forces at many points along their chain. So, as what we have discussed from last meeting, so we discussed that London dispersion forces is a weak type of attraction or a weak intermolecular forces of attraction. So with such liquid na mas mataas yung viscosity, so it means that those particular substances have high viscosity due to the strong intermolecular forces of attraction existing between the molecules. So the viscosity of a liquid decreases with increasing temperature because at higher temperature, the average kinetic energy of molecules that overcomes the attractive forces between the molecules is greater. So with the average kinetic energy of molecules, so meron ding it can also affect the attractive forces that exist between the molecules. So we relate this one to our past discussions regarding the states of solid, liquid, and its kinetic energy. So as what I have said, so the viscosity of a liquid decreases with increasing temperature. So as it lows down or decrease ang mag-decrease ang kanyang viscosity, so that particular increasing temperature causes it to to make it possible that the kinetic energy existing between the molecules will also become lesser. So that is why merong attractive forces na ma-lessen ang iyang attractive forces or ma-weaken ang kanyang attractive forces. So we also have surface tension. So surface tension is to increase the surface area of a liquid. Molecules move to the surface by breaking some attractions in the interior, which requires energy. So for this surface tension, it is actually the energy required to increase the surface area of a liquid. So such that if you're able to see mga species that can actually float in water, example is the seawater. So this is exactly what is surface tension happening to that particular scenario. So if they are able to float in a particular water or in liquid, that is uh, because of surface tension. So if, for example, you're able to see mga water lilies floating in water, so that is because of the surface area and there's an energy or intermolecular forces of attraction between the walls of that particular leaf to the water. So surface tension, like viscosity, is higher in liquids that have higher intermolecular forces of attraction. So with the intermolecular forces of attraction, meaning this can also uh, have a strong surface tension or mas higher iyang surface tension if higher din ang intermolecular force of attraction, or shall we say directly proportional siya with intermolecular forces of attraction. So both properties are temperature dependent because at higher temperatures molecules have more kinetic energy counteract the attractive forces holding them. Surfactants, surface active ingredients such as detergents, soaps, and biological fat emulsifiers decrease the surface tension of water and destroy the hydrogen bonds. So at higher temperature, molecules have more kinetic energy to counteract the attractive forces, or shall we say to pag sabing counteract, it's like to weaken the attractive forces that holds them. So we also have capillarity. So if you're able to see uh, water rising up from the tube, that is actually what you call as capillarity. So capillarity, when you go for simple blood test, the blood sample may be contained by pricking your finger with a needle. So that's an example of capillarity. Capillarity. Um, a narrow tube called capillary tube is placed on the skin opening and the blood rises up through the tube. So capillarity is the spontaneous rising of a liquid in a narrow tube. So if you can see here in the image, this is blood sampling, and then merong capillary action of blood to the tube rather. So we have okay. So capillarity illustrated during blood test. Okay, a concave surface in the tube is due to stronger adhesive forces than cohesive forces, and a convex surface in the tube is due to stronger cohesive forces than adhesive forces. So if you're able to see this one, so the reason behind that is the rising of the blood or any liquid in a tube is called the capillarity or the capillary action. So what happens during pag merong rising of liquid in a tube? It's also when this results when from a competition between the intermolecular forces within the liquid molecules or the cohesive forces and those between the liquid molecules and the walls of the tube. So meaning there is an attractive forces between first the walls, second the liquid molecules, and kanang walls is the walls of the tube, and also the liquid molecules that is forced to go up to the liquid. So that is why capillarity or capillary action takes place. So cohesive forces. So as we have a while ago, we're talking about cohesive and adhesive forces. So we discuss it by one by one. So cohesive forces is the attractive force between molecules of the same substance, and adhesive is the attractive forces between molecules of different substances. So if it and counteracts to other substances, then that is adhesive force. So we also have okay. So when water is placed in a narrow-mouthed tube, the surface of meniscus takes a U shape or concave because adhesive forces are greater than cohesive forces. So in mercury, the meniscus is curved downward or convex. So this one, okay, we'll have a highlighter. Okay, convex because the cohesive forces metallic bonding are stronger than the adhesive forces. So meaning it's the stronger ang cohesive forces, meaning same metallic bonding with mercury than the adhesive force that comes within the tube. So that's it for the cohesive and adhesive forces. So capillarity is also observed in the transport of water from the roots to the other parts of plant. So we take a look back or we relate our study with or this study with our lesson from biology class. So do not forget we're dealing with chemistry right now, but syempre biology and chemistry is quite related with each other. So we relate capillarity to the action of the xylem and phloem. So if you're able to see or diba, you'll ever learn that xylem takes in mga water molecules that comes from the roots and then absorb it, and then later will be distributed to the body parts of the plant, the stem, the leaf, and the other parts of the plant rather. So that is due to the capillary action that takes place when water is absorbed from the xylem and it's now goes to the other parts of the plant. So, do not forget this one. So, that is, syempre, in order pa rin. So we also have evaporation, vapor pressure, and boiling point. So with this one, makaingon jud mo that we are now dealing with water, or we're dealing with specifically dili siya water specifically with liquid, as we talk about evaporation, vapor pressure, and boiling point. So this is referring to liquid. So when liquid particles of the surface of a liquid have enough kinematic energy to overcome the attractive forces of neighboring molecules, they escape into gaseous or vapor state. This process is called evaporation. So, such that, okay, we always talk about temperature. So with with the presence of temperature, there comes a time when katong liquid is overcoming the attractive forces because of the change in temperature. So that is why evaporation takes place. So they escape into gaseous or vapor state. So when evaporation occurs in an open container, some particles collide with each other or with air molecules and return to the liquid, but most of them escape until the liquid evaporates completely. So, okay, let's have, okay, my pointer. So, evaporation which has reached equilibrium with the liquid surface is said to have reached saturation. Okay. However, molecules in a closed container are trapped as the vapor particles increase, some collide with liquid surface and return to the liquid state. This is known as condensation. So, if you're particular with condensation, evaporation, so asa man na siya ninyo always madungog. It's from the water cycle. So with the change in temperature, it can actually make an event or process of evaporation and condensation. So for that, so as vapor particles increase, so if there is an increase of vaporization, so 'di ba, the liquid becomes, say ito kana, liquid becomes vapor, and then, okay, it collides with the liquid surface and it all can return to its liquid state. So that happens for condensation. So, okay, let's have a sample here. So A, okay, molecules of liquid in a closed container reach equilibrium with its vapor after some time. So when there will be equilibrium state, then it can actually goes back to its liquid form. So B, molecules of liquid in an open container escape from the liquid until all the liquid evaporates. So if you can see here, the difference between the two samples are with the covering of the container. So ang isa kay walay, okay, ang isa with a covered, close is it's a closed container, walang isa kay wala. So this liquid samples is different from each other due to the container itself. Okay, so this letter A can actually be katong condensation state, while for letter B, that is for evaporation. So there will be an escape of of liquid that go with evaporation. So mo na mag-evaporate ang liquid, so it can now escape the container.